This is Algebra 2 with trig, section 5.3. We're adding and subtracting polynomials. We're going to look at this first one. This is one way you could set it up. Set it up in a vertical fashion. So we're going to keep our like terms together. So our constants give us -3. There's no x's in the bottom row, so you just have the 4x. Subtract, get -7x squared. And then grouping these two together to get our 4x cubed. Remember, when you're collecting like terms, you're not going to change the exponents. You only change the exponents when you're multiplying. In this horizontal fashion is where you're going to see it a little bit more often. When you're adding two polynomials together, there's really no need for the parentheses. The plus a negative just gives you a -4y squared. You still have the 3y and the -9. So your like terms, there's only one term in here with the largest exponent. And then we have a 7 and a -4 to give you 3y squared. And with the y's to the first power, -6 and +3 give you -3, and we end with -9. Again, like terms, you do not change the exponents when you're grouping those together. Only if you were multiplying. This is not a FOIL problem. People typically try to multiply through or do something crazy like that. So when we're going to subtract, you're taking one polynomial and you're going to subtract another. We have to take this and distribute it through all the way. So you're going to have your 7 minus 6x squared minus 3x plus 7. Distribute this through to get a -6x cubed, a -3x squared, a +7x, and a -5. Then when we collect our like terms, we get 2, which is a +2. We get a +4x. We get a -9x squared. And we get a +x cubed. Notice that the larger number is positive, so that's why you have a positive. They're both negative, so the larger number is negative, so you're going to end up with negative. The larger number is positive, you end up with a positive. Now, in a horizontal fashion, where we usually see it, you need to also distribute that through. Now there's no need for this parenthesis. In fact, I wouldn't write it because that often leads you into multiplying later. I would leave it as 8t plus 6 minus 5t squared gives you a -2t cubed, a +3t squared, and a -7. You're looking for your largest exponent. Largest exponent's the 3. So we're going to say -2t cubed. Your next largest would be 2's. So you have -5 and +3, so that gives you also a -2. These are t squares. The 8t, and there's no other t's involved, so this is a +8t. And then the +6 and the -7 give you a -1. This is in standard form because we start with the largest exponent and we work our way down. That puts that into standard form. In multiplying, when we multiply two binomials together, we use what's called FOIL. But in this case, we don't have a FOIL because we don't just have an outer, inner, first and last. We have a trinomial that we're multiplying. So we think about this a little bit more like double distribution. We'll do the double distribution actually on this side. This one we're going to I'll show you how to use the box. So we're going to make our box. We have a 3 by 2. So we have our 3x squared, our negative x, and our 4. This is already in factored form, so that's why the factors are on the outside and not on the inside of the box. With an x and a 2. So we start to put this together. We're going to multiply here. Multiply the x with the 3x squared to get 3x cubed. The x and the x, negative x squared. The x with the 4. So now we come down to the 2 and we do the same thing. The 2 and the x squared, negative 2x, positive 8. Now, it's kind of fun to see. If you look diagonally, the like terms are always together. So you're going to have 3x cubed. Here you're going to get a positive 5x squared. Diagonally here, we're going to get a negative 2, actually positive 2x with the constant of 8. And that's in standard form because we're starting with the largest exponent and working our way down. Now we're going to look at it more in our traditional double distribution. That's when we're going to take the x value and multiply it to all 3 pieces of the trinomial, all 3 terms of the trinomial. That gives us a 6x cubed, a positive 3x squared, and a negative 5x. The 2 would go to the first term to get negative 12x squared, negative 6x, and a positive 10. So we collect our like terms. We look for the largest exponent first, and the largest exponent is the 3. So we have 6x cubed. For our x's, we're going to see a negative 12 and a positive 3 gives us a negative 9x squared. The x's give us negative 11x. And our only constant is the 10. So here we are, we're taking 3 terms. When we have our 3 terms, we're going to multiply through to get our first term. Foil this, and then we'll have another one to distribute through just like we did previously. It doesn't matter which 2 you work with first. I often like to work with the last 2, and then I have my x minus 3 sitting in front, and it just works out in a nice organized fashion. Gives us x squared plus x plus 7x plus 7. We still have the x minus 3 sitting in front. Now before I distribute that through, or double distribute that through, let's clean up. I got some like terms. X squared plus 8x plus 7. Now it's like what we did up in example 3b. You could use the box method, or you can use the double distribution. An x cubed, an 8x squared, and a 7x, negative 3x squared, negative 24x, multiply the last terms to get negative 21. So this is going to give us an x cubed. Our like terms here would be the positive 5x squared, a positive 8 and a negative 3. Our x's, we have the positive 7 and the negative 24 to give us a negative 17x with the negative 21. So looking here in terms of our foiling, I actually foiled it in a different order, and I got that, and then I multiplied through by my x minus 3. These notes we're talking about doing it in a different order. You would get the same result. It doesn't matter what two you want to start with. So you go ahead and try this one. You can pause the video now, and we can come back and see the finish. Alright, hope that went well. Let's check out what we do. Okay, I'm going to do it like I did the first time here, to be with x squared plus 5x. Negative 6x, negative 30, with my x plus 3 before it. That leaves me with x squared minus x minus 30, x cubed minus x squared minus 30x. So we have an x cubed, a 2x squared, a negative 33x, and a negative 90. Any concerns with that? Great. Alright, we've talked about some special patterns in terms of multiplying before. We had the difference of two squares. That's if you had a term minus another term. The way you could write that, it's a term squared and another term squared. The way you could write that was with your two sets of parentheses, your AB and your AB with your plus or minus in between them. That's called the difference of two squares. We also talked about the perfect square binomial. So if you know you're going to have a perfect square trinomial, then the pattern that's going to multiply out to be is your first term squared, your last term squared, and the middle term being 2 times those two multiplied together. A lot of times we've been talking about factoring, and when we work the other direction, we test it to see, do we have a square root of this, square root of the last term? Is the middle term 2 times those two multiplied together? But if we're trying to multiply it out, expand it, then we're going to also be able to use that pattern. If there's a minus in between for your perfect square binomial, or squaring a binomial actually, not your perfect square, sorry. If you're going to square your binomial, then you're still going to get your a squared, you're still going to get your b squared, you're still going to get your 2ab. So all that matches. The only difference is going to be the negative sign. If it's a minus here, it's going to be a minus inside your trinomial. If it's a plus inside the binomial, then it's going to be a plus inside the trinomial. Alright, let's try these. We're going to multiply these two together. Well, we could do it the long way, where we multiply them out for the FOIL format, but what I want you to recognize is that these are opposites of each other. They're considered conjugates, right? So the middle terms always cross out. So you get your first terms to be 49m squared. You'd get a positive 21 and a negative 21. Those would cross out, and you'd be left with a negative 9. Here we have a binomial being squared. So what we've learned, regardless of what this term is, it's your A term being squared. It's your B term being squared. It'll be a plus because that's what's inside the binomial. It'll be 2 times those two multiplying each other, and plus your B squared. So when you square this, you square your 4 to get 16. You square your t cubed to get t to the 6th. 8. Here we're going to say 8 times 6. It gives you 48. T cubed. And then a positive 36. It was probably a little fast. If you want to FOIL it out the normal way, you're definitely welcome to do that. What we're trying to get you to see is some patterns. These are the fast patterns to be able to do, and you don't have to FOIL it all out. You're squaring your first term, you're squaring your last term, and you're doing 2 times your 2 terms in the middle. Let's try letter D. You go ahead and try letter D. You can pause the video and start it back up again when you're finished. Alright, so let's try that. We're going to take our 6q, we're going to square it. We're going to take our 3r, we're going to square it. We're going to use the minus 2 times those two multiplied together, and always add it to your b squared. So this is going to give me 36q squared minus, let's see, we're going to say 18 times 2 to give us 36. That's going to be QR. And then we're going to end with 9R squared. Okay, now here are some new ones. This is following this pattern that's sitting up here. This is the cube of a binomial. Okay, this is your binomial and you're going to cube it. There's a pattern that goes through here. We're going to learn the much larger patterns. This pattern is doable. You can do this. Look at your A term. We start out the first term with A cubed, and then A squared, and then A to the first, and then A to the 0. the b term works backwards. B cubed is last, b squared is second, b is third, and then just the b here will be the last thing you write. Then you have these coefficients that are always 1, 3, 3, 1. You also have it very similar to your fashion over here, where we're going to take the a term and start out with a cubed, a squared, a to the first, a to the 0. B to the third, B to the second, B to the first, B to the 0. With the 1, 3, 3, 1. The pattern, when you have a minus in between, is going to be a positive, negative, positive, negative. It alternates throughout. I would just suggest to keep track, call this a negative b, and it'll work itself out for you. Let's try it. So we see here that our a term is xy. And our b term, let's call that negative 4. So I'm supposed to say my my a term cubed and my a term squared and my a term to the first power and my a term to the 0 power. When it's to the 0 power, we can just write 1. We can call it xy to the 0 if we wish. So now we're going to take our b value and do negative 4 to the third power, negative 4 to the second power, negative 4 to the first power, negative 4 to the 0 power. Well, it's really no need to write it if it's to the 0 power. It's just a value of 1. Then we have our coefficients to put in. We have our 1, our 3, and our 1. A lot of times we'll start with the coefficients and then build around it. So let's simplify this. We're going to get x cubed, y cubed. Positive 3 and a negative 4 gives you a negative 12, x squared, y squared. This gives us 16. Negative 4 squared is 16. 16 times 3 is 48. A positive 48. xy. And then negative 4 cubed is our negative 64. A negative times a negative times a negative is clearly a negative. So let's look at our pattern. A positive, a negative, a positive, a negative. It made that pattern for us since we used the negative for the b value. If you're going to fake it and just put them in automatically, then you've got to treat the b as a normal 4. Let's try this one. Our a value is 3x. Our b value is 2y. So let's start out with our coefficients this time. Let's do 1, 3, 3, and 1. Got to space them out well. Take your a value, which is 3x, and cube it. Take your a value and square it. Take your a value to the first power and your a value to the 0 power. You know to the 0 power is just a value of 1. So now that's really 1 times 1. Then we can start down here and take your b value to the third power, the b value to the second power, to the first power, and to the 0 power. We just won't even write it because it's just a value of 1. And you have pluses in between them all. It's just a pattern. It's way easier than trying to multiply this all out. Especially when that 3 might become a 5 or a 7 or a 10 in the future. Don't give up on this pattern of seeing, this method of seeing a pattern. So 3 cubed is 27. The x cubed. We're going to square the 3 to get 9 times 3 times 2 is 54. X squared y. If you need to write that out a little bit slower and show all your steps, that would make a lot of sense. This is going to make 4 times 3, which is 12 times 3, which is 36. Your x is to the first power, your y is to the second power. 1 times 1 drops out, and we just get 2 to the third power, y to the third power. Way easier than trying to cube the trinomial.